Hello and welcome to this video where we're going to take a look at linear inequalities and systems of linear inequalities. So the first question to pose is, what does it mean to be a solution to one of these linear inequalities? So we're going to begin by taking a look at the example, is 3, 2 a solution to x plus 2y is greater than 1? Now the way I can test that is take the inequality, plug in 3 for x and 2 for y. So in this case, I'm going to get 3 plus 2 times my y of 2. And I want to know, is that going to be greater than 1? So then I continue to solve. 3 plus 4. So I end up with 7. And I want to know, is that greater than 1? Well, obviously it is. So yes, it is going to be a solution. If for some reason this comes out to being not true, then it would not be a solution. The careful part is watch out that you're dealing with an inequality. So if I end up with something like 3 is greater than or equal to 1, that's going to be true. If I end up with 1 is greater than or equal to 1, that's going to be true. So these are both going to be yes situations. But if I end up with 1 is greater than 1, that's going to be a no situation, because there's no equals. Okay, so just be careful with what the inequality sign is. When I look at beginning to graph the inequalities, I'm going to show this by doing an example. So I'm going to look at y is going to be greater than x plus 3. Okay, my first step is to graph the line. It's what's called a boundary line. So in this case, I'm going to look at where y is equal to x plus 3 is. So if I'm going to go ahead and graph that, okay, I would begin with my y-intercept of 3, and my slope is 1, so it means I go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up, okay, and then kind of begin to work my way back down. Okay, so I begin having kind of this line that's forming. Okay, you'll notice that I leave it as dots. The reason being is that the boundary line will be dotted when it's greater than or less than, and it'll be a solid line like how we graphed the lines before, when it's greater than or equal to or less than or equal to. So this goes back to how we graphed simple inequalities when it was just less than, with just one variable, with the open circle versus closed circle. So the solid line is like the closed circle, where the dotted line is like the open circle. It still leaves space. So in this case, I'm going to leave this as being dotted, and I'm just going to put the arrows on the end. The second step will be to do the shading. Okay, if it's greater than or less than, if it's going to be greater than or equal to the sign, you're going to put your pencil on line, and you're going to shade up, because the y value at that particular x value, the y value needs to be larger than that line or greater than that line. If, however, it's less than or equal to, you're going to shade down. Okay, so when I'm looking at this, to show the shading, okay, I'm going to put my pencil on the line, like so. If it's greater than, I will shade straight up from there. If it's less than, I'm going to shade straight down from the line. So in this case, since it's a greater than symbol, I'm going to put the pencil on the line, and I'm going to shade up, which means I'm going to shade this region of the graph. Okay, I kind of cut that colored in. That means that any point that falls in this section of the graph needs to be a solution. And I can check that. So for example, one easy point to check is 0, 0. If I pick 0, 0, is 0 going to be greater than 0 plus 3? So is 0 going to be greater than 3? No. So it's good that it's in the not shaded region. Okay. But if I picked a point like here, let's put 0, 4. Is 0 when x is 0, when x is 0, y is 4. So let's try that. Is 4 going to be greater than 0 plus 3? Basically, is 0 greater than 3? This one checks, which means I've shaded in the right region. Now when we begin to look at graphing systems of linear inequalities, I'm going to use the same process. So in this case, let's put y is going to be less than or equal to 2x minus 1, and let's say y will be greater than x plus 4. We're going to graph each of these lines individually. Okay. So I'm going to begin with the first one. Since my y-intercept is -1, put a point here, my slope is 2x minus 1, so I'm going to go up 2 to the right 1, 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 down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, and I'm going to end up with a line looking something like this. Okay? Since it can equal, I'm going to draw a solid line. For shading, since it's less than, I'm going to put my pencil on the line and shade straight down. So I'm going to go ahead and shade that region, like so. And this is where, if you have colored pencils, to represent each line with a different color may be very helpful to you. For the second, I get y is equal to, and let's change that to -x plus 4. So if I go to graph that, my y-intercept is at y equals 4. It's -x, which means I go down to the right, down to the right, down to the right, down to the right. Okay, I begin to get a line. So I'm going to make this a dashed line because it's going to be greater than. Okay, then I go to shade. I put the pencil in line. Since it's greater than, I'm going to shade up. So that means it's going to be this region. Okay. Now what you will notice is it divides into 4 regions, the plane into 4 regions. This has no solutions whatsoever, okay, in either inequality. This region here is just the green, so just solutions to the second inequality. Down here is just blue, so it's just solutions to the first inequality. But this area here where there's 2 colors, show me where they overlap, where there's solutions to both inequalities. So what I need to do is, just to clean this up, I can either put solutions here and somehow mark it, or even better, do a second graph to kind of clean it up a little bit. Okay, sorry, it's really hard to draw with my finger. -1, slope of 2, Looks something like that. Hopefully drawn better with pencil. And then to show where it's in common and where my solutions are very clearly, I mark it. Now there's no way of really writing this other than drawing it using this graph with this shaded as a way of showing where the solutions are. So once again, anything in this region would be a solution to both inequalities. So hopefully it's been helpful. This is what we're going to work on over the next couple days.